All right, so we are going to start today by looking at some properties of logarithms. So last Friday, we kind of just talked about what a logarithm is, how it relates to an exponent, kind of going back and forth between the two. If you were gone last Friday, you're going to really need to make sure you go back and watch the video that was posted on Friday to really understand what we're talking about here. So we are really going to be stretching the rest of this unit out quite a bit from what we would do if we were in class together. So we're going to take it super slow. Please make sure you are engaging in the live conferences if you have questions and emailing me, and I'll do my best to kind of walk you through this stuff if and when you need help. And so one of the big things we talked about on Friday was how a logarithm and an exponent are inverse operations of each other. So that also means that some of these properties are also going to be related. So just to review, remember if you have an equation that's b to the x equals y. So we've got this exponential function. You can rewrite it as a log base b of y equals x. So when you're changing back and forth between each type of form, you always take the same approach. If you notice here, the base of our exponent is the same as the base of our log. That's always going to be the case. And then when you're going to rewrite it, like if you kind of watch, I'll go this way first. So you always start and you go around and then back. So log base b of y equals x. Okay. And then when you're going this way, you would do the same thing. So b to the x equals y. You're always going kind of back and forth between those two forms. And there's plenty of examples of that on the notes from Friday. Right now, I want to keep this video as kind of short and sweet as possible. And so we're going to jump right into these first two properties. And properties of logarithms are going to be helpful when we start solving equations using them kind of farther down this unit. And so if we look at this kind of related exponent property, right here. So we're taking x to the fifth times x to the sixth. Well, when we multiply these together, to condense it from 2 to 1, we add the exponents. So kind of the inverse is going to be true with the product property for logarithms. If I have log base b of m plus log base b of n. Well, when we're solving these equations, our goal is going to be to combine what we call like terms, right? Just like in any other equation. So here, if I took two exponents that I was multiplying together and to combine them, I added, now the opposite is going to be true for a log. If I'm adding two logs together and I want to combine it into one, I would multiply the contents of the log. So it's completely opposite. Multiplying condensed to 1 by adding, adding condensed to 1 by multiplying. So this whole conversation about exponents and logarithms being inverses of each other is also true with the properties. So the same thing is going to be true with dividing, right? If I wanted to simplify this expression from two exponents to 1, I would take 8 minus 3 and get x to the fifth. So the inverse is now going to be true. So here I subtracted to go from 2 to 1. So if I'm subtracting two logs, log base b of m minus log base b of n, to condense that from two logs to 1, I'm going to divide. So I'm going in the opposite direction. So log base b of m over n. Okay. So again, just to kind of show you, opposite. Multiplying to adding, adding to multiplying, dividing, subtraction, subtraction, dividing. Everything is inverted. Okay. All right. So let's see how that kind of comes into play as we are working on, we're going to look at expanding them. So kind of going from one log, expanding it out into 2 or 3, depending on what's we're looking at, or condensing the expression, which is this is what we're going to use more when we are solving. Okay. All right. So what you want to ask yourself when you're looking at this, I say log, and then if that base isn't written in, remember that means it's base 10. So log base 10 of 10x. Let me see if I can focus this more. Oh, come on. There we go. That's a little bit better. Log base 10 of 10x. So you kind of want to ask yourself, is there multiplying or dividing? So if I were to say this would be 10 times x. So that would be like the contents here. So that m times n is really 10 times x. So if we just kind of look at here and work backwards, this is what we're trying to get to. So I'm going to take the contents of the log, the m and the n, and I'm going to split them apart. So this then would be log of 10 plus log of x. Okay. Now, every once in a while, we may need to simplify this one step further, right? So I said right here, if the base of our log is 10, ask yourself, if you just have a numerical log, can that be simplified? Is 10 to a power 10? That's what we ended class with last time. 10 to what power is 10? So this is actually 1 plus log of x, and that would be my final answer. Now, you're not always going to be able to do that, but here's a case where you can. So if we look at this next one, I've got the natural log of 2x. So if I'm looking, okay, am I multiplying or dividing? Well, I'm multiplying the 2 times the x, so that would be like my m times n, 2 times x. So I'm going to pull those two things apart with addition. So this would be the natural log of 2 plus the natural log of x. So now I see my numerical log right here. The base is e, but there's no power that will get me exactly 2. E to no whole number power will get me 2. So I can just leave my answer like that. Okay, so now here I see division. Okay, so I see 2 over y. And so if I'm trying to expand that out, I'm going to take the contents, so the 2 and the y, and I'm going to pull those apart by subtraction. So notice we still kind of do like the order of operations. So my numerator is always first, followed by my denominator. So this would be log base 3 of 2 minus log base 3 of y. Here's my numerical log right here. Ask yourself, does 3 to a power equal 2? Nope. So that one's done. So now this one, we're kind of taking it one step further because I see that I'm dividing, but I also see that I am multiplying right here. So this one's going to be kind of like an additional step once we get to the end of it. So here I'll take the division apart first. So I'll have the natural log of 6 minus the natural log of 5y. Okay, this part is going to be complete because I can't take e to a power to get 6. So that's going to stay natural log of 6. But now there's my m times n, 5 times y. So we have to be careful here because I'm subtracting this whole log. And so when I take that apart, I have to take that into consideration for the 2 logs that I'm now going to create. So I'm going to put parentheses there, natural log of 5 plus natural log of y. So I'm subtracting that entire quantity. And so now that final answer, if I want to distribute that negative through, would be the natural log of 6 minus the natural log of 5 minus the natural log of y. Okay, now keep in mind this, when you're writing the natural log, I don't know why, every year people write it I-N. It's not an I, it's an L, natural log. Don't write an either. Okay. All right, so now we are going to kind of go backwards. Now we're going to be condensing the expression. So we're trying to go from multiple logs down to one. So this first one is log base 2 of 8 plus log base 2 of 3x. So here's a case I don't want to simplify this because I'm trying to combine into one log. And so I want to keep this as log base 2 of 8. So let me think, all right. And when I'm adding two logs right here, I multiply them together to condense it to one. Excuse me. And so if I'm going to now take log base 2, I'm going to write this one out kind of the long way for this first time. So I'm going to multiply 8 and 3x. Okay, well, when I do that, I just get 24x. And then I'm done. Okay. And so now this next one, I'm dividing because I'm subtracting here. So I'm going to take log base 5, that first part is always going to be your numerator, divided by 5y. And then just like in any other fraction, if you can simplify it, absolutely do that. But I can't here. 4 and 5 don't have any common factors. So I'd be done with that one then. All right, and then these last couple, now I'm going to kind of make it a little bit more adding terms here and then kind of some more difficult terms, I guess, in here. So if I'm adding, I'm going to multiply them to put them back together. So I'm going to have to take 6x times 4y. And so now we multiply together kind of like our like parts. So I can multiply the two coefficients to get 24, and then x times y. That would be my final answer there. All right, so now when you've got 3 or more terms that you're adding or subtracting, you work from left to right. So the first thing I'm going to do is multiply these first two logs together. They're both in base 10. The base is not given there, so we can assume it's 10. So 6 times 10 is 60 minus log of 3. And now I'm going to divide. So log of 60 divided by 3. So here's a case where I can simplify. And so 60 divided by 3 would be 20. So this is going to be the log of 20. Okay. And we can't simplify that. I cannot rewrite 10 to a power to get 20. So that I would just leave my answer like that. All right, so now we're going to kind of end with just a quick little review of what we did on Friday. So kind of putting it to these equations, going from logs to exponents to solve for the variable. And so we kind of just looked at something like this last week, and now I put an equation with it, and then we're looking for kind of different parts of all of these logs. So remember, log and exponents are inverses of each other. So if you want to rewrite all of these logs as exponents, which is something you guys are more familiar with, it's going to be a lot easier to evaluate what you need to evaluate. So if I rewrite this, 4 to what power is 16? 6 to the third equals x, and then 5 to what power is 1 over 125. So visualizing it like that is probably a lot easier for you guys as opposed to looking at it as a log. However, I do need you to make sure that you can see when you see a log, kind of picturing that as the exponent. If you can do that, then you are good to go. So then this one, answer the question, 4 to what power is 16? That would be 2. 6 to the third is going to be our answer, so we just have to type that in. to our calculator. We get 216. And then 5 to what power is 125? Here's one of our special cases. Whenever we're going from a whole number to a fraction or vice versa, a negative exponent will do that. So since 5 to the third is 125, that means that -3 will be your answer to that. Okay. All right, so now if you go on Canvas, there is a short homework assignment that is posted. And then you'll take a picture of your work and submit it for attendance purposes and for a homework grade. And so since you're hopefully watching this on St. Patrick's Day, if you snap a little selfie of yourself working on your math homework wearing something green or St. Patrick's Day festive, I will give you a bonus point on the quiz you will take later this week. If you have any questions, hop on to the live Canvas conference. I'll send you guys the time. I'm recording this on Monday, so I'll send you the time tomorrow on Tuesday, or you can message me any questions that you have if you can't make it to the live conference.